Hi, welcome to lesson 1.4, perimeter area in the coordinate plane. So one of the things that we're going to look at in this lesson is if I were to give you a set of coordinate points, it's obviously going to create some type of polygon in the coordinate plane. So what our goal is to find the perimeter and the area of the polygon by using prior equations like the area of a square, the area of a rectangle, So let's start with our exploration on page 17. Now on page 17, what we're going to do is we're going to plot these points right here. The first point we're plotting is point 1, 4. So 1, 4, this is going to be A. The next one is 3, 1. That's B. The next one is 0, negative 3. That is C. And the next one is negative 4, 0, which is D. So what we're going to do is we are going to, I believe I got something wrong. 1, 4, negative 3, 1. Whoops, my bad. Okay, that's not where that goes. 0, negative 3, and 4, 0. I guess I'm not awake yet, guys. It takes me a couple of minutes. It's 8 o'clock in the morning right now in my room. So, there you go. These are the correct points, okay? Instead of editing, making mistakes is part of learning. So we're good with that. All right, so we're going to connect the points. And what looks like a square is actually a square. Now, how do we know that this is a square? Well, if you look at the slopes of these lines, you get 3 over 4. And then for this one is 4 over 3 going in the negative direction. So these have opposite reciprocal slopes, which we're going to cover a little bit more in chapter 3. Therefore, these are perpendicular, making this an actual square. Now, I'm going to focus on one thing here, okay? If I want to find the perimeter is the length around the polygon, okay? Now, this is in centimeters. It tells you right here. It's a centimeter graph paper. If I were to graph my ruler here, I can actually verify that these are indeed centimeters, okay? Let me get a clear one, probably a little better. Okay, so you can verify that these are indeed centimeters. So if you were to measure this, okay, this is approximately going to be 5. Now, I could also do Pythagorean Theorem. I have 4 by 3, okay, 3 square plus 4 square equal to c square. Now, we will be doing Pythagorean Theorem in the future, but it is a prior knowledge. So we get 9 plus 16 equal to c squared, gives me 25 equal to c squared. Take the square root and you get c is equal to 5. So this length right here happens to be 5. Now all of these right here are 3 by 4, 4 by 3, and 3 by 4. So all of these will have a length of 5. So the perimeter of this polygon is going to be 5 plus 5 plus 5 plus 5, or 5 times 4, which happens to be 20. So the perimeter is 20 centimeters. And don't worry about these two. Oh, you can't see that. Okay, let's move on to page 18. Now on page 18, we have exactly the same diagram. Okay, same coordinates. Now what they want us to do is that they want us to find the area of this polygon. Now it says here, quadrilateral ABCD is partitioned into 4 right triangles and 1 square, as shown. Find the coordinates of the vertices for the 5 smaller polygons. So we actually kind of did already. We made these into all right triangles right here. Then it's asking me to find the area of the triangle. But here's the thing. All of these triangles are the same. Now, one of the things that we have learned from the past is that the area of a triangle is 1/2 the area of the base times the height. So if we take, for example, here triangle 1, Okay, the length of this triangle right here is 1, 2, 3. So the area is going to be 1/2 times 3 times 4. That's going to give me 12. 12 times 1/2 is 6. So the area of this triangle right here is going to be 6. So area of BPA, that's BPA, that's this one, is the same as this one, and this one. So for this one, it's going to be 6. The area of AQD is also 6. The area of DRC, where's D? DRC is also 6. And CSB will also be 6. Now the only thing that's missing is this little square right here, and that area is going to be 1. So if I add up all of these right here, 6 plus 6 plus 6 plus 6, that would be the same thing as 24 plus 1. The area is going to be 25 centimeters square. Well, I shouldn't really call them centimeter squares because they're not referring to them as centimeters. So instead of centimeters square, let's just call them units square. So that is how you can partition a polygon into different polygons so that we can actually find the area of the figure. Now, for our examples, you are going to need a couple of things. Okay, you are going to need 3 pieces of graph paper. Okay, you're going to need 3 pieces of graph paper, and you are going to put examples 2 right here, example 3, and example 4 right at the bottom. So go ahead and get those ready. And you're probably wondering, where is example 1? Example 1 is on the previous page, page 1, right there. Okay, so on page 18, example 1 is going to go here. Simply cross these off. And example 2 is going to go right there. 2, 3, and 4. All right, so let's move on to our examples. All right, here is example number 1. It says, classify each polygon by the number of sides and tell whether it's convex or concave. Now, within the lesson, they do tell you what is a convex and a concave polygon. Okay, a convex polygon is where if you have all the diagonals stay on the inside, it would be considered a convex polygon. If any of the diagonals lie either outside or partially outside, then it's going to be called a concave. So to test this, all we have to do is draw all the diagonals. All the possible diagonals. As you can see, all these diagonals remain inside. So this is going to be a convex polygon. Now, how many sides does it have? 1, 2, 3, 4, 5, 6. It has 6 sides. So therefore, this is going to be a hexagon. This one here has 1, 2, 3, 4 sides. Therefore, it is a quadrilateral. Call it quadrilateral. But the problem is that one of the diagonals, it's going to lie on the outside. Therefore, this is not a convex polygon. This is going to be a concave polygon. So that's mainly the difference between convex and concave. So we classified it by the number of sides. This has 4 sides, and this one has 6 sides. We let n represent the number of sides. So that's example number 1. Example number 2. Let's go ahead and graph these. You have -2, 3, -2, +3. That's A. You have 3, -3, 3, -3, that's B. And you have -2, -3. Now, lucky for us, this is a right triangle. So what we're going to do is connect these. Now, to find the perimeter, we need to find all the lengths here. So here you got 1, 2, 3, 4, 5. This is going to be 5. This is going to be 1, 2, 3, 4, 5, 6. 6. So we need to estimate what AB is going to be. And we're going to, again, use Pythagorean Theorem, which was taught to you somewhere in Algebra 1. So we're going to look for distance AB. So AB is going to be 5 square plus 6 square, which is going to give me 25 plus 36. And that's going to give me a total of 61 degrees. Now, our next thing is, oh, I forgot one thing. Don't forget the square. So when you are solving for AB, you have to take the square root of 61. So let me open up my calculator. And here, we're going to take the square root of 61. And it happens to be about 7.8. So AB is the square root of 61. So the square root of 61, it's approximately to the nearest tenth, about 7.8. So now to get the full perimeter, we need to add 6 plus 5 plus 7.8. So 6 plus 5 plus 7.8, whoops, 6 plus 5 plus 7.8. The answer is approximately 18.8. Now, I want to give you an alternative method for doing this problem. Now, to find these distances, you know, that's easy. But here's the thing. What if in your class we have not covered the Pythagorean Theorem? One of the things that you can do also is the distance formula to find out what this is. So let me show you really quickly how that's going to look like for the distance formula. So for the distance formula, we're going to find the distance between A and B. Okay, so to do that, we're going to do the differences of the x's and the differences of the y's, quantity square. So here, the differences of the x's are -2 and 3. So -2 minus 3. And difference of the y's, that's 3 minus -3. So that's going to leave me with -5 square plus, that turns to addition, and that's going to give me 6 square. When I keep simplifying, that's going to give me 25 plus 36, which is the equivalent to the square root of 61, which is going to give me approximately 7.8. So this is a different method, and I believe for this lesson, instead of doing Pythagorean Theorem, go ahead and do the distance formula. But if you feel more comfortable with Pythagorean Theorem and you're, want to go ahead and do it like that, then I'm okay with either or. But for the sake of this lesson, stick with the distance formula. Okay, example 3. Find the area of the following polygon. D is 1, 3. That's D. E is 4, -3. So 4, -3, that is E. F is -4, -3. So what we're going to do after you plot those points is connect them and create our triangle. Now we know that the area of a triangle is 1/2 the base times the height. Now we are lucky here that we can actually have our base easily counted. So 1, 2, 3, 4, 5, 6, 7, 8. So 1/2 the area of the base times the height. So our base here happens to be 8. And our height happens to be the vertical distance from the top point perpendicular to the bottom. So 1, 2, 3, 4, 5, 6. All right, so now we got 1/2 times 8 times 6. That is the same thing as 1/2 times 48, which is going to give me a total of 24 units square. So the area of this polygon is 24 units square. Let's look at example number 4. Okay, in example number 4, it says you are building a shed in your backyard. The diagram shows the 4 vertices of the shed. Each unit in the corner plane represents 1 foot. Find the area of the floor of the shed. So they want me to find the area of this. Now, in order to find the distance from here to here, I have to count 1, 2, 3, 4, 5, 6. So this length right here is going to be 6. I know it's kind of dark to see in there. So if you were to draw your little rectangle over here, that's going to be 6. That's going to be 1, 2, 3, 4, 5. That's going to be 5 units. Okay. So now what we need to do is actually find the area. The area is going to be 6 times 5, which is 30. So the area of this diagram right here, the background, is going to be about 30 feet square. Okay, ladies and gentlemen, that does conclude our lesson today. So thank you for coming up, and thank you for showing up.